Alright, as I was putting this together, I just realized I didn't have the restrictions on the domain like I was supposed to. Each of these should have a restriction. We talked about that up above, that the restriction was to be the right half or the positive half. We get that from the h value in the vertex. So let's see, the vertex is, let's go over the vertex. So the vertex on this problem is going to be -2, 0. There's a +0 out here. So the restriction, let's just put an R for restriction. The restriction will be x values that are greater than or equal to -2. So that'll be the restriction on that domain. Okay, over here, our vertex is 3, -4. Right, there's your vertex. So the restriction will be x values that are greater than or equal to 3. So just take that first value in the vertex. H is going to be the opposite of what's in the parentheses. So in that case, it's +3. All right, let's go down to the ones below. Okay, so my vertex is 7, 9. That's the vertex. All right, take the opposite of the one in the parentheses. So my restriction will be x values that are greater than or equal to 7. And let's see, last one, the vertex is a little harder on this one because there's two parts in it. It's not just plain h. So to figure out what's going to make that equal 0, if I have 2x minus 5 equals 0, I add 5. I get 2x equals 5, divide 2. So the vertex is going to be 5 halves, 0, because there's nothing after the parentheses. So the restriction would be x values that are greater than or equal to 5 halves. Okay, we need to restrict the domain whenever our exponent is even on all quadratics or parabolas because they're not one-to-one. So anytime you get a polynomial like this with an exponent of 2, 4, 6, or 8, it won't be one-to-one. We need to restrict the domain based off of the vertex.